Alright. Do you have it open? Zach, do you mind reading the next one to me, please?
The speed of light
Yeah.
through a rectangular block of glass is 2 times 10 to the 8 meters per second.
Okay.
A. Determine the refractive index of
Oh,
glass.
okay. So that's just going to be 1.5, isn't it?
Yeah.
Yeah. Okay.
3 to 2.
Yeah. Easy peasy. Right, B?
A ray of light is incident at an angle of 60 degrees to the normal on the rectangular block of glass, which is immersed in a tank of water. The refractive index of water is 1.33. Part 1. Copy the diagram above and complete the path of the ray through the block and emerging
Oh,
through the
is it like this is the water here?
and then the block is suspended here.
Like this? And which way is the ray coming in? From the left or the top?
The left. So the normal
So-
is straight.
Yeah.
Yeah.
And how far? They want you to do the whole path, is it?
Yeah.
Okay, so it will come in at 60, like here in the picture.
No,
It comes in at the top of the block.
Oh, that's what I was asking. Okay,
Oh,
so it's like the normal is here,
Yeah.
and it comes in from the right,
The left.
the left. So it comes in here,
60.
and that's 60 there.
Yeah.
And then what's happening to the index? It's gone from 1.3 to 1.5. So
1.33.
do you know what? I need to maybe zoom in a bit, make this a bit bigger. Right, there's the water. And then how big is the block? About this big?
Yeah.
Yeah, okay. And then there's the normal. And then there's the, what do we say, 60.
Yeah.
So that's about like that. And then it will refract and its angle will get bigger, won't it? Ugh, can't draw today.
Complete the path of the ray through the block and emerging through the other side.
Yeah. Now, it doesn't quite go straight, of course. It gets bigger. But I don't think it will hit here because of the way I drew it. So I need to make my block longer. Come on. No, sorry. What am I saying? It gets smaller, doesn't it?
Yeah.
I have it backwards, sorry.
5 to 1.3.
So it'll go like this.
Yeah.
Okay, and then it'll hit here. And then now it'll get bigger.
Yeah.
So instead of going straight, it'll get bigger. So maybe it goes like that. Goodness. Okay. Right. It's a bit messy. Sorry about that. What's the next thing they ask?
Determine the angle to the normal of the beam of light after it has entered the glass.
Is this C? Part C?
Yeah.
Yeah.
Part B2.
Oh, yeah, okay. So, oh, Diego, why are you late? Oh, rats. It's not, okay. Maybe next week. Okay, sine 60. Sorry, did they want the angle here or here? What did they say?
In the glass.
In the glass, is it?
Yeah.
Yeah.
Sine
After
60.
it has entered the glass.
Okay, so that's N2, yeah, over N1. Yeah, okay, so I hope you got the theta here, okay? What did you get?
Sine inverse.
Yeah,
50.2.
50.2. Okay, what's next, Zach?
Questionnaire. It's the next question.
Oh, good. Okay. Did I upload the answers yet for that question?
No.
No, it must be an older exam then.
Yeah, it's 11, 12. This one's even older, 10, 11.
Okay, 8.
It's over.
A. A ray of monochromatic light of frequency 1.6 times 10 to the 14 hertz is incident on the surface of a glass block at an angle of 38 degrees to the north. The glass block has a refractive index of 1.54.
Yeah.
A. Determine the angle of refraction of the ray of light inside the glass block.
Okay, so that's 38.0 degrees. Yeah, over sine theta equals 1.54 over 1. So theta is, that should be easy peasy, I hope. Did you get theta?
23.6.
23.6 sounds reasonable. And the next part?
B. Calculate the wavelength of the light as it travels through the glass block.
We could use yeah.
But you don't know the wavelength.
Well, okay, so we can just say, oh, we do, don't we? There it is there. Oh, we know the frequency, yeah. So they want the wavelength in the
Glass block.
glass. So that's equal to V over F in the glass. But that's the same as V over F in the air, because the F doesn't change. So that's V over C over. Oh no, we do know. It's given.
Yeah.
It's given. Oh, so. Oh, but we don't know. We don't know the V. Yeah, sorry.
Well, you know the V in air.
Yes.
Yeah, but we need. Sorry, I didn't write it down here. This is the V in glass. Oh, we can easily know it. We know the refractive index for glass.
Yeah.
So it will be C over N. It'll be slower over the F that we know. All right, so we just bash those three numbers into the calculator. Well, I suppose if I want to clean it up, it's C over NF. So that will be 3 times 10 to the 8 over 1.54 times 1.6 times 10 to the 14. I have a feeling that these two guys will cancel the 3, and I'm probably going to be left with 10 to the 4.
10 to the minus 6.
10 to the minus 6?
Why did it see?
It's 10 to the 14. So
Oh, thank you. So 10 to the minus 6 is the answer, is it?
yeah, 1.22 times 10 to the minus 6. So 1.22
Whoa, that's not 6.
mega.
No, minus 6.
Mega.
Yeah, but we usually do wavelengths in nanos, so it's 1.22 nanometers.
Would that be 1?
Oh, sorry.
1,220.
Yeah, it would be, wouldn't it? 172. Yeah, 1220 nanometers. Wavelength of light is represented usually in nanometers.
10 to the minus 6 is what?
Micro.
Micro.
Okay, are we okay with that, folks? Yeah?
I think this one you're going to need the background.
Okay, well, I'll open it up.
It's a glass prism.
Yeah, I'll just load it. It'll be easier. No, not forbidden. Right. Physics workbook.
Reflection.
Right.
Question 9.
We're at 9, okay. Oh, yeah. I have to have a look at this. Okay. So what have you got? You got your light, it enters the glass, there it is all shown, the glass has that index. And the first thing is state smell. Okay, I don't think I need to do that. Sine theta 1 over sine theta 2 equals n2 over n1. More interesting is calculating theta. Well, actually, that's okay. That's okay.
Yeah.
So,
That's just sine theta 1 over sine theta 2.
yeah, sine theta over, what's it, sine 24? 24.
1 over.
Why do I keep getting my long number with all of these things?
Over
I
n2
get the same.
over
1.
1.
I get FaceTime calls. Like they call me, 2 seconds after they just hung.
What?
Okay, so what do you get here?
Speed it up one way.
What you get?
38.8.
38.8.
Yes.
30, yeah.
Yeah? Okay. Next, determine the angle of incidence of the ray on the face AC. So, I'll have to draw this a little bit.
You see, I didn't know which way from.
Yeah, we'll draw it.
Just answer it and say who.
Can I answer?
Hang on, what number is it? Why don't we just do a Google search on the number?
01491.
491.
01491 1402.
01.
01.
01 stuff.
Or is
01 is Dublin.
Dublin.
Oh, no. 001. It's
01, sorry, go ahead.
491
491
1402.
1402. Let's see if
For
that's.
me, it's like Harvey Norman wants you to. take
Oh,
a survey.
again.
I thought you were
How they
finished with them.
service us.
Oh,
They're like, Pete, right? I'll service us."
can I give you a negative?
Let's see.
-3. The guy came yesterday.
Yeah. Funny story. So I don't know where it's
Why
from.
is your name Pete?
Oh, I died.
Oh, interesting. That's the phone number for Travelodge in Rathmines.
That's me. That's definitely me.
That's legit?
That's legit. I booked the hotel.
In Rathmines?
Yes.
That's not very far away.
I know.
Oh yeah, he's coming today.
Yeah, he's coming today.
Sure.
Oh, this is for someone.
Yes.
Yes, okay.
When is he
So do
coming?
I call or not? Oh, I don't. He should arrive around.
It's probably just a call to confirm the booking.
Well, what do I do? Or can I call him later?
Yeah, of course you can.
Oh, that'll be fine, right?
Yeah. Did you pay for the room already?
Why? Yeah. I mean, we don't have to pay it after, but they hold an amount because I booked it through Booking.com.
Yeah.
Ah, so that's perhaps why they want to confirm, make sure you weren't a bot or something.
But I'll call them later.
You can call them back, you'll be fine, yeah. Right. So, let's draw this here. What's the... Okay, so it comes in here at an angle that we know. We just worked that out. Although it's actually not useful anymore to us. And then it goes off at an angle here.
24.
Now, yeah, this is 24. But what we really need to know,
That one.
this one here. Now, we'll have to do some careful thinking to figure this out, okay? So that's 24.
Then you got Joe.
That's 30. Okay, that's 90. That's 60. That's 120. So together that's 144. So that makes this one 38, doesn't it? Yeah? Oh, sorry, I forgot how to add. 36.
So 90 minus 36.
So that's 54.
Yes.
Alright, well that's fine. That's fine. So that's 54. And then they want the critical angle. Oh, that's annoying. In no way was that used for anything else. Calculate the critical angle for the glass. Ah, easy. Sine inverse, what was the refractive index?
1.12, so 1 over 1.5.
Yeah. Yeah, easy peasy. Okay, so that's the critical angle.
40.5.
Okay, you got that?
Mistake.
Oh, there's more?
Yeah.
Ah, okay, fine. So we did need the 54. So, internal or not?
Yes.
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 It's,
Now, we actually learned that internal means, okay, so the light will come back in. I think this here will be 54. I think, didn't we have a diagram that had
Yeah, it was
this?
the same.
But then some of the light continues on through,
Mhm.
like this.
No.
You don't know, it
No.
was like...
If it's-
Oh, sorry, for
when it
total
enters-
internal, you're right, it doesn't, yeah.
when
It's
it-
only when it's
when it
Uh,
goes out,
it's
yeah.
yes, then,
critical angle.
44.5.
Yeah. Yeah. Yes, you're right, it's less than that. Okay. Did you do the next one? How far are you along?
I finished the next one.
You did 10?
I didn't do this one. I just looked at it on the
I
note.
did. It's not. I
You
don't
did
know
this
if
one?
Yeah.
Did you get it right?
I didn't check the answer yet, but I did get answers.
Oh, okay. It's a hard one. How many people tried this one? No? No? Just Dorian? Okay.
I checked the answer now.
Yeah, okay.
What was this?
Because I'll do it, but I want you to at least give it a go first.
I'll check if I got it right.
Gina, did you try this one? No.
Oh, is it the fish that, oh no, the boy is trying to spear the fish.
Yeah.
Have you seen the fish that hunts by
That one?
spraying jets of water and like hitting insects or plants as well? And it knows how to see the angle because of the refractive index is different.
Oh, it comes out
Yeah, it
under
can
the water.
compensate. So it shoots from under the water and it changes the angle.
Nice.
It's smarter than.
Smart fish.
Were you right?
Wait, I'm still trying. What was the?
We're looking at 0607
Okay.
semester 2 version 2.
Semester 2 version 2 AA.
Yeah.
I feel like I did not get it right. What? Wait, where is it? Okay, I got the first part right. Then the second part also right. Oh. Why did I get it wrong at this point?
Okay, good.
Okay, now I have to.
Can you give it a go for about 5 minutes, and then I'll try to give you the answer. It's a hard one. I don't like it.
What he sees is a virtual image.
Why?
So just to be clear in the picture here, the fish is really here,
Yeah,
but he perceives it as being at B, because his brain will think naturally that the light is travelling in a straight line. So he thinks the fish is here at B. Yeah.
His father's a fisherman, not a physics teacher.
Yeah, okay.
Oh,
You think you got it?
I messed up the sign and pan.
I was going to ask you what was with the shirt today. It's not your usual style. Your shirt.
My shirt.
Not your usual style. And then I
Trying
realised,
to-
oh, there's somebody coming to
No,
visit.
no.
Now I'm starting to connect
that's,
dots.
that's not it.
No?
That's not
Okay,
it.
alright.
I'm trying to avoid all black.
Okay.
Because Chinese military. Yeah.
Is it bad luck or something?
Well, try not to all black. You're not all black. That's fine.
Huh? What's wrong with all black on Chinese New Year?
Chinese New Year, see? Bad
So
luck.
unlucky.
Bad luck.
Ah, interesting. Interesting.
Superstition, I know.
You're in trouble, Zach. You're wearing all black
I've
there.
got grey pants on.
Alright, okay, fine.
Green shirt.
Wait, what was it? Mhm.
Did you spot your mistake, Dorian?
Yeah.
Yeah?
And do
Did I get it right? Yeah, I got it right. Okay. I did this and then I did this.
You
and
got
then-
it though?
Yeah. Then I fell asleep. That was-
Okay, let's have a look at this now. So, the first thing they want is the refractive index, which is this angle here.
Mhm.
Yeah, because the light comes in and then it bends. Like that. Okay? So that's sine 30 over sine theta. Is it 1.33 for the water?
Yeah, 1.33.
Okay, so what did you get for the theta here?
22.1.
Yeah, 22.08, 22.1 then.
Sorry, I heard it.
Yeah. By finding CP, calculate CB, and then finally AB. So they want us to first get this distance, is it? Well, let us see. We now know this angle, which means we know this angle.
And you can get the other one.
Yeah, we could get the other ones too. So this side here will be okay. So we'll have to call this side something like x. So we can say tan 22.08 equals x over 1.2. So CP will equal 1.2 tan 22.08, and what's that?
Oh, wait. 22.08. 0.487
Meters.
Yeah.
Okay. Now, how can we get this distance? Let's see. So what do we know?
Well,
We know that this is 30 here,
so you know
and we so.
that one is 30.
Now I have to be really careful here not to mess this up. This is a straight line.
Yeah, so that one is 30.
No, this here, this dotted line to this is straight, isn't it? I know it doesn't look like it on my picture, but it
That's
goes
what I
like
mean,
this.
So 30 up there,
Or
it's
is-
also 30.
No, it's not. It's not.
This is 30.
That's what I
No,
mean.
that's 60.
No.
No, that's
That's 30. It has to be
It's
30.
30.
Okay. Yeah.
That's 30.
Yes.
Because it's strict.
Yeah, because it's straight. So that's
So that's
60,
yeah.
Mhm.
and that's 30.
Yeah.
So if I call this side y, then I can say tan 30 equals x over y. It is hard to see, isn't it?
It's not really to scale at all.
Y equals x over tan 30. Okay, so now, yeah? Yeah?
Mhm.
Well, what did you get for y? Hopefully a number smaller than 1.2.
Why isn't?
This is here to here.
Wait, what did they ask for?
0.7
They asked for CB,
divided
tan 30.
0.8435.
Yes.
0.844 then.
Yes.
Alright, well, and the last part is just the difference. AB will equal 1.2 minus that number. So what do you get for AB?
357.
Huh?
357 6.
0. Point, sorry,
0.356.
sorry, very messy question.
Scale is horrible.
Yeah. Did you get it okay in the end? Yeah?
I didn't know that one.
Say again?
I didn't know that one.
Can I continue?
Yeah.
Yeah? So let's see what's happening in the next one. Okay, this looks like a question where it's the light goes from air, oil, water. I think what's happening is you have a glass of water, something like this, and there's oil sitting on the top, isn't it?
It's a pond.
What is it? A pond. Okay. And the light then would first hit the air, and then the oil, and then the water, in that order, it looks like.
We said yesterday that it didn't really matter if it traveled.
Yeah, what were we calculating? The speeds. The speeds is not affected by the material the light came from. But are they asking for any speeds here? No, these are all angles. Okay, I think everyone can do this in a couple of minutes, it's no big deal. You're finished, Zach?
So it's from oil to water, right?
Into oil first.
No, yeah, that's 27. And 20.
Oh, it's the oil first.
It's the oil first. Okay.
Alright, you got it finished?
Yeah.
We're going air, oil, water, isn't it? And the oil, so it starts off with 42.6, huh?
With index 1.48.
Sine 42.6 over sine theta 2 equals, what is it?
1.48.
Okay, so that's easy peasy. You get theta 2, don't you?
Yeah, 27.216.
27.216 and so on. Then the next one is sine 27.216 over sine theta 2 will equal, and then now it's 1.48 on the bottom and 1.33 on the top. Is that right? Yeah. So then theta 2 this time is
20.1129.
1129. And then lastly, the critical angle between the two.
$63.981.
63.98, so that's 70.
64.
Huh? 64?
Wow, yeah, 60.
Point.
0.981.
Okay, so that would have to be 65.0.
No, 63.98, so 64.
63.98, thank you. So that's 64.0 degrees. Yeah?
I said 63.
Sorry, I don't understand your Spanish accent. Right. Okay. You got that? Easy peasy? Yeah? Let's have a look at the next one. Yeah, okay. Interesting stuff happening here. Give that a try.
Air, water, glass, air.
Yeah, air, water, glass, air.
If you have a vacuum, what number is it?
1.
1 also.
It's like air.
Does parallel sided mean?
Those lines are parallel in the diagram. that it?
I'm just figuring out something.
Now, shall we look at the answer, or what's the story?
Yeah.
Yeah. Let's have a look. We want to draw the diagram first. That's a little tricky. Okay. We start off, what's the first one? Air, is it?
Yes.
So, okay. We have air, water, like this, yeah?
Glass.
Glass,
Okay.
then air again. Okay. And the first angle?
42.6.
42.6. No, 35.
Oh, 35.
Sorry.
Sorry.
Yeah. 35. Okay. And 35. So what'll happen now is it won't continue straight. What's the refractive index here? 1, 1.33, 1.5 and 1. So the refractive index increase, that means that the angle here decreases. So there it goes there.
It decreases even more.
No, I don't think I drew this. And then it, oh goodness. Okay. Then it decreases again. Oh no, start over. How will I make this easier? If I make the first angle look much more than 35. There you go, alright. 35. Okay, so let's see. Right. Decrease. So there. Okay. And then dot blue, dot green, dot blue.
Looks almost far.
And is it not blue?
No,
What is it then?
purple.
That's not purple, is it?
It is purple.
Yeah, it is.
That's blue enough. Right. Okay, so then it'll be like this. And then do we need the last one as well?
Yeah.
Oh my goodness, okay.
No.
Oh, good. I forgot, it changes here. Whew, okay. Determine the angle of refraction as the ray enters the glass block. The glass block. Okay. So look, I'm going to put some angles here. I'm going to call this one here, can you see? Theta 2. So this angle here, No, this one. theta 2. Okay. This angle here, theta 3. This angle here, theta 3. This angle here, theta 4. Okay. And refractive index, please. 1,
1.33.
1. And which angle do we want as the ray enters the glass block?
Theta 2.
Theta 2. Okay. That's okay. So that's okay, isn't it? So we have sine 35 over sine theta 2 equals 1 over 1.33
over 1.
over 1. So what's theta 2 then?
25.5.
25.5. Okay. And then what do they want next? Uh-oh. What have I done? What number were we doing?
Just down there.
Huh?
Down here.
No.
Where did it go?
Determine the angular fraction as the ray leaves the glass block. So that's the last one, theta 4. Okay, so let's see. You can say sine 35 over sine theta 2 equals 1.33 over 1. You can also say sine theta 3 over sine theta 2. Theta 3 over theta 2. So 1.5 over 1.33. And then you can say sine theta 4 over sine theta 3. 1 over. Now let's and we know theta 2, so that's helpful. Okay, and we want theta 4. So we need to know sine theta 3. So I can put this in here and I can say sine theta 4 over 1.5 sine theta 2 over 1.33. You see how I rearrange this one? Sine theta 2 coming up here. That's equal to 1 over 1.5. So that means theta 4 will be sine inverse. And what happens is when you cross multiply here, I think the 1.5's cancel. And you're just left with sine theta 2 over 1.33. Yeah?
What's the result?
I don't know. You tell me.
This is for theta 1.
4.
Theta 4.
Yeah.
But the answer I got was different.
Okay, well first tell me what this is.
I got a different answer.
Yeah, me too.
Okay, well first tell me what this is.
18.9.
Okay, now let's check the answer please and see.
Which one is this?
This one is 1415. Semester 2 version 1.
Semester 2 version 1.
A7.
A7.
35.
Ah,
Dorian, 35.
okay, I did not get 30. Oh, why did I write 30.5?
What is the answer?
35.
I'm wrong?
Yeah.
No, dudes.
Why did I write it?
Well, what was the previous answer?
Well, 18. Your answer or this answer?
Your answer was 18.9.
Yeah. And their answer?
35.
So it's done.
What was the previous answer? Did I get that right?
Yes.
Yeah.
So it's the last part. Maybe I did something stupid with my fractions. Okay, can we look up? Is this right? Sine theta 4 over sine theta 3 is... That's right. And is this one right? Sine theta 3 over sine theta 2? No, hang.
Sine 2.
Oh, there's my mistake. Guys, look. My mistake was here. I wrote 3, 2. I should have written 2, 3. Ah, okay. So, that means sine theta 4 equals 1.5 sine theta 3, and sine theta 3 is 1.33 over 1.5 sine theta 2. And what did we say sine theta 2 was? 25.5. Can someone check that, please? Oh. No, they don't cancel, do they?
Sign what? Sign G.
Okay.
Uh, 14.74 should be.
For theta 4?
That? gives you 14.74.
That's not the right answer either. Alright, children, help.
What's the one on the bottom again?
It was 1.3.
No, the right now.
1.5
It's 1.5.
But that they're saying that's wrong.
times sine.
Yeah, it's wrong.
Oh my goodness, I'm doing something stupid with my fractions. Alright. Oh, who's calling me? Who's this number?
Sure you
Travelodge, is it? Someone from Galway?
Galway. Should we also research that number?
Galway? Who would be calling me from Galway? I don't want to talk to someone from Galway right now. Right? Galway? That's amazing. I don't know anyone there. Alright, what have I done stupid here with my fractions? Okay, let's check. Sine 35 over sine theta 2. Sine 35 over sine theta 2 equals 1.33 over 1.
Yeah.
Okay, we're good.
Wait, no.
No, it's not.
Yes.
Okay,
I'm
don't freak
looking
me
at
out,
sine-
Dorian.
No,
Right.
I'm looking
The
at
other one
sine.
is sine 3
Okay,
Go.
sine
okay, hang on. So that should be, we said, 2, 3.
And the other one should
Sine
be
2, hold on. Sine 2 over, sine theta 2 over sine theta 3 equals 1.5 over 1.33. Okay.
Next one is wrong.
That one should be 3, 4, is it?
Yeah.
Sine theta 3, right, okay. So, I forgot what I'm looking for. Sine theta 4 equals sine theta 3 over 1.5. Sine theta 3 is 1.33 over 1.5 sine theta 2. No,
No.
no,
That's the same we had.
no, that's a dirty lie.
Sine theta.
I'm having trouble with my fractions. 1.5
Sine.
sine theta 3.
Yes.
And sine theta 3 is 1.33 over 1.5 sine theta 2. Cancel, cancel. Sine inverse 1.33 sine 25.5.
34.9.
Oh, sweet. What is it?
34.9. So 35.
34.9.
Okay, that was stupid. Sorry. Alright. Next one. Next one looks easy peasy.
That's it.
I think we've seen one like this, right? Let's see who was calling me. mystery number.
Question 14 is the same as question 10.
Exactly the same?
Yeah.
Really?
Oh, but maybe just a different version of it.
And question 15 is power and.
Power?
Oh yeah, they have pump power in.
Oh yeah, it's weird that they mixed it.
It's not exactly the same, is it?
It is.
Yeah, something like it.
Which question what again?
14. Look at the
Which question what?
the one we did with the fish and the bone. Trying to.
Oh, you're talking about. Oh, okay, sorry, no, because mine is at still at 15. It's the case.
Do you have 13 done now?
Refresh the page, Dorian.
I don't want to.
Do we have 13 done?
Yeah.
Wait, one more.
It's like yes, no? Were we doing 13, wasn't it? Or were we, sorry, what were we
Yeah,
doing?
yeah,
13.
Currently.
ID 185. What is the refract? Okay, so that first one is okay, I hope.
Mhm.
Sine 40 over sine theta equals, what's the end here?
46.
1.33 over 1.
Yeah. 1.
Alright, well that's all fine, isn't it, I hope? What do you get for theta 2?
46.5.
46,
46.56,
46.
is it?
4.
4,
6.
6,
So.
4.6, I see, okay. Okay, what's the next part here? The wavelength in the water. So the wavelength in the water will equal V in the water over the frequency in the water. But the frequency in the water is the same as the frequency in the air. So V over the V water and frequency in the air is the same as the formula is C over.
No.
Oh.
That's,
It's given.
Yeah,
No.
it's given.
Oh, it's given in the glass, is it?
the frequency was given. The last
Yeah.
one.
Well, the frequency. Okay, so
It's the same.
it's the same. It doesn't matter what I use here. I could use glass, couldn't I? Yeah. Do we know the V in the water?
No.
Okay, so that's the one where it'll be C over N in the water over F in the glass. So that will be C over NF. 3 times 10 to the 8. What's it for the water? 1.33, is it? What's the N for water? Is it
Yeah.
1.33. Yes.
Yeah, and then the frequency here is 6.06 times 10 to the
14.
14. Right. What do we get for that? So
3.72 times 10 to
Where
the power
did they give you the
7.
frequency?
The
Oh,
first
sorry, I'm looking at the
10 to the power of minus 7, is it?
Yeah.
6.6.
So that's 372 nanometers. Yeah.
Yeah.
Did you get that answer?
Yeah, I did.
I just noticed now there's some colour in your hair.
Yeah, you dyed it.
Yeah, and I've only just noticed that in the last few seconds. And I guess I'm a bit colour blind. I don't notice colour so well. When did you do that?
Yesterday night.
All right, okay. For Chinese New Year?
Just because.
Just because, okay. Did you get that? Yeah? Yeah? Okay. Alright, easy peasy. What's the critical angle? So that'll be sine inverse 1.33 over 1.5. So what you get for that?
62.5.
62.5.
Yeah. Is it okay? Yeah? Great. So we don't need to do 14. I should have that marked as ignore.
You need to
Because
remove it.
yeah, it's exactly the same. I mean, it's the same because they copied the question, I think, in that paper. So I need to remove 290. And I kind of don't like 373 because they mixed it with
Power
power. So
and specific heat. Yeah.
yeah. So sorry, what numbers did I say? 290 and
290
and 373. I'm going to just mark those as ignore or delete. And are 16 and 17 exactly the same?
Looks like it.
Oh yeah. It
Yeah.
does look like.
No.
There's one thing that's different.
Yeah, okay, so they're technically not the same.
Only
Oh,
one.
although you can't actually do 17 because of a mention of something called photons.
But like in 17 and 18, the only difference is in B part 2. One is 2.5 meters and one is 1.5 meters.
Yeah,
That's
but there's another thing in it that means you can't do it.
And
Oh,
what is
yeah.
the wavelength of a photon?
A pho-
Photoelectron.
No, it's I'm more concerned about how much energy is carried by the photon. So you haven't done that one. Oh, so does that mean the rest are all not applicable?
Mm-hmm.
Wait.
290,
Maybe we can.
373.
We can't do all of question 16. We just can't do part A2.
And 3.
Yeah. Yeah. No, you could do A2. You should be able to do
Part
A2.
A3, I mean.
Yeah.
The others should be the same.
No, I think that maybe wraps us. Can you just leave that open for a second? I'll just remove those ones. So edit database. Edit physics database. Okay, can you just tell me please the first ID number of the first question we need to delete? Yeah.
290.
290. Okay, let me just. Wow, I've gone slow. My processor is working hard to load the page. Yeah. Oh, come on, dudes.
If you ask me, it's faster than me.
My computer's gonna make 1 year next year. Like 10 years.
Like 10-year anniversary.
10 year anniversary. I might just skip it.
290 we said, isn't it? Yeah. So I'll just mark this one. Ignore. Okay. And then what's the next number?
373.
373. Okay.
Easy.
I think what we'll do, we'll start the next wave lesson.
Okay.
What was the next number? Sorry, 373?
Yes.
Come on, come on. Oh, come on. There we go. Okay. Okay. Did I get the update button? Yes. And the next number?
326.
336, okay.
Ignore it because, but.
You can move 336 to the photon whenever we learn photon.
No, I don't like it because then when I get to it, I'm like, why am I doing a photon question that has critical angle in it? So I'll just ignore it later then. Come on, this is the
So
intro.
maybe
It's
But it
so-
looks kind of interesting.
All the questions are interesting.
The early exams they like to put
They did, yeah. Oh, I might have to delete this later. I should write it down. I'll just write it down in my notebook. I know, it's great. I got it in the Euro shop and I like it. It's like €1.50. Looks nice, fits my bag well. Okay, so what do I need to do? I need to mark
ID
Ignore. on, yeah, what are the IDs?
336 and 352.
336 and 352. Now, I don't know if this one will load. What one was I just doing there?
You were just doing 373.
373 or 372?
373.
Uh-oh.
Oh.
I might have accidentally marked 372 here as ignore. Unless I meant to do that one. Oh yeah, that does look, no. Maybe.
I think it
That's
was ignored
one.
previously, yeah.
Okay.
It was like that before. Yeah.
Okay, so actually, no, so I don't need to worry about that. That one looks like it's sorted. Maybe it's working now. So then it's just going to be 352. Okay, well, let's start the next topic.